So when we talk about the off-ball principle, we know that we fill the lowest energy orbitals first before we start filling the higher energy orbitals. But there's an important exception to that, and the exception revolves around this D block. And the exception can kind of be said like this. Atoms would rather have a filled D block than a filled 4s block, or they would rather have a filled 3D block than a 4s block. So what can happen is if I'm 1 electron away from having a filled 3D block, or I'm 1 electron away from having a half-filled 3D block, I'm actually going to take an electron from the 4s block and bring it over to the 3D to make it half-filled or filled. And so there's only two elements that we need to talk about then, and that is copper and chromium. And so why these two elements? Well, copper is 1 electron short of having a filled D block, and chromium is 1 electron short of having a half-filled D block. So what we have shown here is the normal electron configuration that you would imagine for copper. And so as you see on this top one, I have a filled 4s2, and then I have a unfilled 3d10. So what is it going to do? It's going to instead exist as it does in this bottom example. So this top example is incorrect, and here I've taken this one electron and I've moved it into the D block. So now it exists in the D block. And so even though I only have 1 electron in the 4s block and I have an entire filled 3D block, this is actually preferred. It's more stable. So this is like the only case where you're really going to see a violation of the off-ball principle. Now, here is the other example. Give the electron configuration for the 4s2 and 3d10 subshells for chromium. So like we said, chromium has 1 electron short of a half-filled D subshell. So what it normally would look like before we take that into consideration, would be this. 4 electrons, 1 in each of the orbitals of the first 4 orbitals of the D block, and then we have our 4s2 filled. But so we'll just take one of these electrons out, move it over to the D block, and then that is chromium in a more stable state.